to trigonometry regions, the hyperbola. So a couple of notes about the hyperbola. There's really two basic types, and I have them illustrated here in their formulas of standard form. But they look very similar, don't they? And so what's really the difference? The difference is the lead variable. The lead variable on the left is x squared, and then it's minus y squared. But the lead over here is y squared minus x squared. And so that's the key difference between these two types. And so this hyperbola, because the lead is x squared, it will have x intercepts. If your lead is y squared, it's going to have y intercepts. And so what does a hyperbola look like to begin with? Well, first, this first type of hyperbola will look something like this. Because it has x-intercepts at plus or minus a, and this is very similar to the ellipse that we did in the previous lecture, where the number below x squared, we do the square root of that, and that gives us the intercepts for that axis. And so whatever that number is, that'll get us, something here, and then something here. It's a little sloppy. Let me fix that up a little bit. Sorry, a little delayed on my tablet, but hopefully it'll pick up a little. So a little one there. And so those are my x-intercepts. But it does not have y-intercepts because a hyperbola is not an oval or a circle like the circle and the ellipse are. The hyperbola instead looks something like this. It's a disconnected graph. It's almost like if you cut a oval in half and then flip the two halves around. And so this is what your hyperbola looks like. And so you see that it does not have y-intercepts. It only has x-intercepts. And we get those from the square root of x squared. Now, on the other side, when your lead variable is y squared, instead, the square root of the number below y squared is not going to get you x-intercepts. It's going to get you y-intercepts. And so then you would have y-intercepts at these locations. Let's say here and here. And so it's just like the other ellipse. It's basically just instead of going, left, right, it's basically up and down. So these are really rough sketches here, but I think you can get a kind of a picture of what this is supposed to look like that. So these are your two ellipses. Like I said, it just looks like this one just turned 90 degrees. And do you have x-intercepts or do you have y-intercepts? And it all depends on what your lead variable is. But other than intercepts, this has something that we haven't really discussed yet. It has asymptotes. Now, an asymptote, let me just give you a little definition of what an asymptote is. It's a line the graph approaches. So a line the graph approaches but never touches. A line the graph approaches but never touches. It gets forever closer and closer and closer to it, but it never actually gets there. And we have these asymptotes that we draw as dotted lines. Again, very rough sketch here. But they're kind of a guide on how to graph your curves. And because we're doing very basic hyperbolas, they're going to just go through the origin. And there's going to be two of them. And you see that my graph is kind of contained within those dotted lines, those asymptotes. And so that's what we need that as a guide to graph these. And again, we would have them over here too. And so a lot of what we do is determine not just the intercepts, which is pretty easy, but also the asymptotes. And so that's slightly different between the two types. For the lead variable x squared type, it's, again, the square root of the numbers below x and y give us a and b. And so it's a square root of the b over the square root of the a gives us b over a. And it's plus or minus that. Over here, everything's kind of flip-flopped. We have y-intercepts, and instead of the square root of b over the square root of a, it's the square root of a over the square root of b. And I get that probably sounds pretty confusing. So let's graph a couple of examples, and I think you'll see it. And having this as a guide will really help tremendously. So you have to figure out what type we're dealing with first, and I see that in this first example, my lead is x squared. So that means it's a type 1 where it's going to be side to side, not up and down. So the first thing I want to figure out is what are my x-intercepts. And we get those simply from the square root of the number below that lead variable x. And so it's going to be plus and minus 2. So I'll go ahead and graph those locations, plus and minus 2. Next, I need to figure out the asymptotes. Now, the asymptotes, I'll abbreviate ASY, we get from the square root of b over square root of x, plus or minus those. So the asymptotes is a y equals, it's a linear equation, and we're doing plus or minus because we're going to have one with a positive slope and one with a negative slope. And so the square root of b is the square root of 9, 3, over the square root of a, square root of 4, 2. And so y equals 3 over 2x, and y equals negative 3 over 2x. And notice that there's no y-intercept because they go through the origin. So the square root of these numbers gives you these. The trick is remembering, is it 2 over 3 or 3 over 2? And so for the lead x ones, it's the b over the a. And so I want to plot these as dotted lines. So 3 over 2 is my slope. So that's up 3 over 2, up 3 over 2, up 3 over 2. And then same thing on the negative side. And so this is my positive sloped 3 over 2. And now I want to graph a negative slope 3 over 2. It's still 3 over 2. It's just on the negative side. So you can think of it as down 3 over 2 instead of up 3 over 2. But it looks like a declined line instead of an inclined line. And so those are my asymptotes. And that's my guide because now I can draw my curve because I didn't know if I should draw it like that, or if I should draw it like that, or if I should draw it like that. And so the asymptotes are really the guide. And I find the best way to draw these is from your axis out. And so I start at my intercept and I go up, and I want to try to get close to my asymptote, but again, I can't touch it, I can't cross it. So I'll go close. Again, your handwriting is probably neater than mine because you're not writing on a tablet, you're writing on paper. So I'll do the same thing over here. Go close, touch, and like that. So pretty sloppy, but not terrible. The key is your intercept is the closest to 0 as I get. Like I can't go like that. Sometimes people make that mistake. Doesn't work that way. Whatever your intercept is right here, that's the furthest this graph should go. Everything is then behind it. And I pretty much go right to my my asymptote and then follow that. But I can't go in front of my intercept, and I can't cross my asymptote, and so that's what you have to be careful with. We usually don't graph these very often. You have to kind of know what it looks like and know how to get this information. That's really the key. All right, let's do one more graph. Let's do the other type. So this one has a lead of y squared, and so it's going to have a y-intercept, not an x-intercept. And the number below y, sorry, one second. So the y-intercept is going to be the square root of 4 down here, which would then, again, be plus or minus 2. So let me go ahead and label those. But on my y-axis, so be careful with that, you have y-intercepts, not x-intercepts. That's the key difference between x-intercepts and y-intercepts. We're using the x-axis here, we're using the y-axis here. So that's going to be different. My asymptotes is still a y equals, and it's still plus or minus, but the key difference is instead of having the square root of, the b over a, the square root of these numbers, it's the square root of a over b. So instead of the second over first, it's the first over the second. So the square root of 4 is the 2, and the square root of 25 is 5. And so my second square root goes on the bottom this time. And that's really the key difference between, is it b over a and a over b. And remember, a just means the first one. I think that's confusing too about this formula sometimes, that we think, oh, a is under x. Well, no, b is under x on this case. It's just a is your first one, b is your second one. A is your first one, b is your second one, regardless of what's up top here. So when x leads, it's the b over a. When y leads, it's the a over b. And that's what I think makes this the most tricky. So, all right, a slope of 2 over 5, that's up 2 over 5. Again, we're going through the origin here. Up 2 over 5 is like that. And you could fill in some extra ones so that the line's very visible. 2 over 5 and 2 over 5 is here, and so let me throw in a couple extra dashes so you can really see it. And then the negative of that slope of 2 and 5 and 2 and 5, and again fill in a little extra 2 and 5, one in between, and 5 right here. So those are your asymptotes. And so this is going to be pretty wide. You know, if my asymptotes were like this and like this, then I'd be really tight. But because these are pretty wide here. Now, if this was the type 1 with X, they would be restricted in here. But because it's this one with Y, again, I start here. I cannot go further than this point. It's this point and out. But I want to make sure I really ride along those asymptotes. So, oh, wow, that's sloppy. But excuse my poor art. You know, I definitely won't critique you guys for your art skills here. All right, and so that's basically it. We'll practice this tomorrow. You know, having this as a guide will really help determining, all right, is lead X, lead Y? Do I have X intercepts, Y intercepts, and then which asymptote formula are you using properly? Sorry this video ran a minute or two late.